Welcome to our exploration of a pressing and complex issue: the ethics of geoengineering and whether we should manipulate Earth's climate. As our planet faces the dire impacts of climate change, innovative solutions have emerged, sparking both excitement and controversy. In this video, we will delve into the fundamentals of geoengineering, examine recent developments alongside ethical frameworks, and weigh the potential benefits against the risks involved. Join us as we navigate the intricacies of global governance, public perception, and the socio-political implications of altering our planet's climate. 1. Understanding geoengineering. Geoengineering encompasses a range of techniques broadly categorized into two main approaches: solar radiation modification, SRM, and carbon dioxide removal, CDR. SRM techniques, such as stratospheric aerosol injection and marine cloud brightening, aim to reflect a portion of solar radiation back into space to cool the planet. CDR methods focus on removing carbon dioxide from the atmosphere and sequestering it. While SRM could potentially reduce global temperatures quickly, it does not address the root cause of climate change, greenhouse gas emissions, and may lead to unintended consequences. CDR, on the other hand, targets the primary cause but typically operates on longer timescales. 2. Recent developments and ethical frameworks. In October 2024, the American Geophysical Union, AGU, released an ethical framework to guide geoengineering research. This framework emphasizes the necessity of grounding any research into large-scale climate interventions in sound ethical principles, ensuring that society can make informed choices about potential deployment. The report warns that the unintended consequences of large-scale deployment are largely unknown and advocates for inclusive, representative, and just research practices. 3. Potential benefits and risks. Proponents of geoengineering argue that it could serve as a critical tool to mitigate the impacts of climate change, especially as global efforts to reduce greenhouse gas emissions fall short. For instance, a study from December 2024 suggests that solar geoengineering could save up to 400,000 lives annually by reducing temperature-related deaths caused by climate change. However, critics highlight significant risks, including changes in rainfall patterns, impacts on ecosystems, and geopolitical tensions arising from unilateral deployment. The possibility of termination shock, a rapid rebound in temperatures if geoengineering efforts are abruptly halted, further complicates the ethical landscape. 4. Global governance and policy stances. The governance of geoengineering remains a contentious issue. In December 2024, the European Commission's scientific advisors recommended an EU-wide moratorium on solar geoengineering, citing insufficient scientific evidence and potential harmful effects. They advocate for the EU to push for a global agreement to prohibit the deployment of such technologies. Similarly, the German government has expressed skepticism, viewing geoengineering measures that influence Earth's radiation budget as not a viable climate policy option. 5. Public perception and community concern. Public perception of geoengineering is mixed, with concerns about ethical implications, environmental risks, and the potential for unforeseen consequences. In June 2024, the town of Alameda, California, refused to host a climate geoengineering experiment involving marine cloud brightening, reflecting apprehensions about local environmental impacts and the lack of comprehensive regulatory frameworks. 6. The role of research and inclusivity. The urgency of the climate crisis has boosted interest in geoengineering, but experts stress the importance of inclusive and evidence-based research. A report facilitated by the AGU in October 2024 emphasizes that any research into large-scale interventions in Earth's climate system must be grounded in sound ethical principles, ensuring that all voices are heard and that risks and benefits are evaluated before decisions are made. 7. Environmental impacts and consequences. Geoengineering, while potentially beneficial in reducing temperature, poses numerous environmental risks that could disrupt ecosystems. For instance, altering cloud formations or injecting aerosols into the stratosphere might change weather patterns, affecting agricultural productivity and water availability. These interventions could lead to unforeseen impacts on biodiversity, potentially harming species that rely on specific environmental conditions. Scientists warn that understanding these complex interactions is crucial before implementing any geoengineering techniques. This intricate balance between potential benefits and environmental consequences underscores the need for careful consideration and thorough research. 8. Technological and financial challenges. Geoengineering projects require significant technological advancements and financial investments. The development and deployment of SRM and CDR technologies demands substantial resources, both in terms of research and infrastructure. Critics argue that the financial burden of geoengineering could divert funds from other essential climate mitigation efforts, such as renewable energy and conservation initiatives. Moreover, the scalability and effectiveness of these technologies remain uncertain, raising questions about their feasibility as long-term solutions. Addressing these challenges requires a comprehensive evaluation of costs, benefits, and potential trade-offs. 9. Socio-political implication. Implementing geoengineering on a global scale involves navigating complex socio-political landscapes. Decisions about deploying geoengineering technologies could exacerbate existing geopolitical tensions, as countries may have differing views on their implementation. The potential for unequal distribution of benefits and harms raises concerns about justice and equity, particularly for vulnerable communities who may be disproportionately affected by the consequences of geoengineering. Building international consensus and ensuring fair representation of diverse perspectives in decision-making processes are essential to address these socio-political challenges. In conclusion, the ethics of geoengineering are complex and multifaceted, encompassing environmental, social, and geopolitical dimensions. While technological interventions may offer potential pathways to mitigate climate change impacts, they also pose significant risks and ethical dilemmas. As the global community grapples with these challenges, it is imperative to prioritize transparent, inclusive, and ethically grounded research and policy discussions to navigate the uncertain terrain of geoengineering.